Welcome to a brand new course on creating a viral Stickman Hook game. This game has over 100 million downloads on Google Play Store and more than 800,000 ratings on the App Store. By joining this course, you will learn the basics of the Unity and advanced C# programming. This course also will help you to make your own games in the future. Join this course to boost your coding skills and game development skills. See you inside. Hey guys, thank you for joining this course. This is the first video of this course. So let's begin. First thing first, we need to create a project. So open the Unity Hub, choose the editor version. I am choosing the latest LTS version. You can choose any Unity version, but if you are a beginner, then my advice is to choose Unity 2022. Now choose a template. We are making a 2D game, so I am choosing a 2D template. Now give your project a suitable name. Choose the location where you want to save your project and uncheck this option. We don't need this option. Now hit the button to create a project. Okay, this is the first look of our project. So here we are. Now the first thing we need to do is change the scene name. So select the sample scene and rename it. Also, I don't like to work in this default layout. So let's change it. Select the layout and I'm choosing the tall layout. You can choose any layout you like according to your preference. I like our hierarchy and our project tab on the left and our scene and game tab in the middle of the screen. It's not necessary to do so. If you want to use the default layout, you can. So, it's time to add some sprites to the game. Check out the resources folder and download it. Extract this folder, choose all the sprites and drag them into our project. Now, we need to customize some settings in our sprites. Select Stickman Sprite. Change sprite mode from single to multiple. Hit apply. Now open the sprite editor and hit the slice button. You can see the sprite editor automatically slices all the sprites. We need to change the name of these sprites, like select this sprite and give it a name called Paul. This one is Go. This one is Pack. This one is Stop. And this one is Win. Also, don't forget to change the parent point as well. Choose the sprite 1 by 1 and select the parent point and move it to the center of his head like this. Do this with all the sprites. So now hit the apply button and close this tab. As you can see, now we can use these sprites individually. Do the same thing with join sprite. Change the sprite mode from single to multiple and then open the sprite editor, hit apply, slice the sprites and then apply and close the tab. Okay, so it's time to drag our pole sprite into the hierarchy and change the scale to 0.3. Select our main camera and change the camera size. Feel free to experiment with your own input values. Now, move the ball a little bit in the left direction and drag our background image into the hierarchy. Scale this background image and set the order in layer to -10. You can make this image a child object of our main camera. Select background and change drag mode simple to tiles. Now you can extend this sprite. Create an empty game object. Rename it called Ankle. Create an empty child object and rename it called Joint. Under this object, add sprite renderer component. Choose this sprite and reduce the scaling to 0.3. Inside our joint, create an empty child. Rename it called rigid body and add a rigid body 2D component here. Also, freeze the X and Y position of this rigid body. We can create one more empty game object called dash-line. Inside this, add sprite renderer component and choose the dash-line sprite. Also, choose the color to black and just scale it. You can move this joint object anywhere. I am just duplicating this object and move it here. That's fine. Okay, now it's time to create some scripts. So, create an empty folder called script. Now right click, create a C# script called Stickman. Create another script called joint. Change your ball name to Stickman. Now it sounds good. Add here Stickman script. Select both of the joints object and drag up joint script here. Now, double click to open it in Visual Studio. It is time to write some code. First, remove the start and update functions. We can create these functions later. Create a header called player sprites. Now add a serialized field sprite ball sprite. We need to add all of our other Stickman sprites here, like stop sprite, go sprite, back sprite, and win sprite. Save the script and back to the editor. Now attach all the sprites here. Select ball sprite, stop sprite, go sprite, back sprite, and win sprite. It's time to add some important components in the Stickman object. So first, add hingeJoin 2D component. When you add hingeJoin 2D component, rigid body component also add by default. Nothing to change inside the rigid body, so close this. Now inside the hinge joint, we need to change the motor speed to -12.44. You can customize these values according to your gameplay experience. You don't need to blindly follow all these values. That's the way you learn more about game development. Uncheck this component. We can make it active using our script. Now add line renderer component. Inside the position, increase the X value so I can see our line properly. Okay, it's not visible right now, so find the material option and add a default line material. Now you can see this. Our line is too thick, so change the width. And inside the position, change the X value to 0 again. That's it for the line render. Now add a circle collider 2D and check the collider is attached properly to the Stickman object. That's perfect. I drag my script component in the bottom. Now go back to the Visual Studio. We need to give the reference to all the components we add in Stickman object. So add a header called components, private hingeJoin 2D hingeJoint, private rigid body RP, private line renderer, private sprite renderer sprite. Inside the start method, give the reference to all these components, like hingeJoint is equal to get component hingeJoint, RB is equal to get component rigid body 2D, line renderer is equal to get component line renderer, and sprite is equal to get component sprite renderer. Save the script and go back to the editor. Okay, so now open the join script, remove these default functions. Here we need a serialized field private sprite called sprite stick and another serialized field private sprite called sprite unstick. Save the script now and attach sticked and unsticked sprite images. Now open the script again and add private sprite renderer and private game object called dashline. Inside the start method, give the reference to the sprite renderer and also give the reference to our dashline. Our dashline is equal to gameObject.transform.getChild1.gameObject. Now create two public functions, setSticked and setUnsticked. Inside the setSticked function, add spriteRenderer.sprite is equal to spriteStick, and inside the setUnsticked function, spriteRenderer.sprite is equal to spriteUnstick. Now create a private boolean variable called sticked and set is to false. Add this variable in the setSticked function, make it true here, and inside the setUnsticked function, make this variable false. Now create two more functions. One is public void selected and the other one is public void unselected. Inside the selected function, check if sticked is not equal to true, then here we can add a function related to the dashline show. Else, our dashline.transform.local scale is equal to vector3.0. Same, copy this line and add it inside the unselected function. Now create a enumerator function called selectingJoint and add this function to the unselected method. Also, add it in the selected method. Inside the selectingJoint, add a float variable time and set this to equal to 0. Add vector3 variable called startScale and set this to vector3.0. Add another vector3 and scale. This one is equal to new vector3 1.13. Here 1.13 is the present scale value of our dashline object. Now check while time is less than or equal to. Okay, so here we need to add a serialized field private float variable called animetime and set this to 0.1. Add another serialized field private animation curve and call it animation curve. Now inside the selectingJoint, add animetime variable here. Here we increase our time plus equal to time.delta time and add dashline.transform.local scale is equal to vector3.lerp, start scale, end scale, and animation curve.evaluate time. And don't forget to call yield return null. Okay, that's enough for the join script. Save the script and back to the editor. Select both of the joint object and open the animation curve. Select this curve and edit it. Right click here and select edit key and add time to 0.199 and value to 1.600. On the other hand, add time and value to 0. Now open the Stickman script, create a header called anchor and serialize field private game object called anchor and give it a reference to it in the start method, anchor.transform.getChild. Now let's create one more header called variable private. Here we need a private integer called last best position joint and the another integer called last best position selected. And now inside the getChild, add last best position selected dot game object dot get component, add a join script reference dot selected and make sure the selected method is public in the join script. Otherwise, this method is not accessible. Inside the start method, we need to initialize our private integers like last best position joined is equal to 0 and last best position selected is also equal to 0. Now create an update method. Also create a private void check input function and call this function in the update method. Inside this function, check if input.getMouseButtonDown or input.getKeyDown keycode.space or input.touchCount is greater than 0 and create another integer called intTouches and add touches is equal to 0. So copy this line and paste it here. Now change button down to up, key down to up, change touch count greater than to equal to 0 and touches is greater than 0. Inside this mouse button down, set lineRender.enable is to true and addJoin.enable is to true. And inside the mouse button up, set lineRender.enable is to false and addJoin.enable is to false. Now we need some public variables. So create a header called public variables and here add serialized field private float gravity rope and also create one more serialized field private float gravity year and set this to 2 and set this to 0.5. Now inside the mouse button up function, set rb.gravity scale is equal to gravity rope and inside the button up set our rb.gravity scale to gravity year. Now we need to create a logic to connect our joint rb to hinge. So add joint.connectedBody is equal to anchor.transform.getChild. Now create two private variables, private integer best position and private float best distance. Now add here best position.transform.getChild 0.gameObject.getComponent.rigidBody2D. By default, our best position at the start is 0. So we find the first joint and then inside the joint we find the rigid body which is present at the 0 index. Now create another private vector 3 called actual joint position and then add here actual joint is equal to anchor.transform.getChild best position.gameObject.transform.position. Also at anchor.transform.getChild best position.gameObject.getComponent join dot set stick function. Also copy this line and paste it here and change the set stick to unselected method. Now add last best position join is equal to best position and also set our rb.angular velocity is to 0. Now create another header called bool and add private boolean value called stick and by default this is false. Now add this here stick is equal to is not stick. Now go to the get mouse button up here, set rb.velocity to new vector 3 rb.velocity.x and rb.velocity.y. Create two public variables called vector x and set this to 1.2 and create another one called vector y and set this to 1. Now multiply vector x with rb.velocity.x and plus this vector y with rb.velocity.y. Now here add anchor.transform.getChild last best position join dot game object dot get component join dot set unstick method. Check if best position is equal to last best position joint. Then anchor dot transform dot get child best position dot game object dot get component join dot selected method, and copy this line and paste it here. Now change the best position to last best position selected and selected method to unselected method. Also set sprite render dot sprite is equal to ball sprite. Now add rb dot add torque, negative rb dot velocity dot magnitude, set stick to is not stick. Also add touches is equal to input dot touch count. Okay, so that's it for the check input function. Now inside the update, add a for loop. I is equal to 0, I is less than anchor dot transform dot child count, and I plus plus. In the current scene, we have 2 joints. You can create more joints if you want. Now set the best position to 0 and best distance to float dot max value. Inside the for loop, create a float actual distance and make this equal to vector2 dot distance game object dot transform dot position anchor dot transform dot get child I dot transform dot position. Now check the actual distance is smaller than the best distance, then our best position is I, and our best distance is equal to actual distance. And also check if stick is true, then line renderer dot set position 0 game object dot transform dot position and line renderer dot set position 1 is actual joint position. Here we can add a function to change the sprite when a player is stick to the joint. So create a private void function called change sprite and call this function here. Inside the update, add another check if last best position selected is not equal to best position, then anchor dot transform dot get child last best position selected dot game object dot get component join dot unselected function. Now copy and paste this line here. Change unselected function to selected function and change last best position selected to best position. Also make a last best position selected equal to best position. Now save this script and go back to the editor. Now select the Stickman object and drag our anchor object inside the script. Here you can see Unity gives me an error because our joint script name match with Unity's built-in component. So let's change the joint script name. Select the class, press Ctrl plus R twice. As you can see, a pop-up will come. Make sure to check these 3 marks. Now change the script name joint to joint anchor and hit enter. Go back to the editor. Now check our script name updated properly or not and hit play. As you can see, now our Stickman is successfully connected with our joint. So as you can see, there is a problem. So now open the Stickman script again and make sure you can place this line of code outside this check statement. Save. Now open the joint anchor script. Here, find unsticked function and call here unselected function. Save the script and back to the Unity. Now select Stickman object, open the sprite render component and change order in layer to 1. Now hit the play button. As you can see now, this is working properly. If you have any problem, feel free to ask, and you can also check out the source code as well if you are facing any errors. It's time to animate our player. So open the Stickman script. We already write a function named change sprite and it is called here. So it's time to write a logic inside this function. First, we need to check if rb.velocity.x is greater than 0, then we don't need to flip our sprite. So write sprite renderer.flipx is equal to false, and we need to set this to true. As you know, our player sprite by default looking in the right direction. So that's why we need to flip the sprite when player move back to the left direction. Make one more if statement if rb.velocity.x is smaller than 0.7 and rb.velocity.x is greater than 0.7 and our gameObject.transform.position.y is smaller than actual join position.y. If this statement is true, then set our sprite renderer.sprite is to stop sprite. Else, if rb.velocity.y is smaller than 0, then set our sprite renderer.sprite to go sprite. Else, set sprite renderer.sprite to back sprite. Now save the script and go to the Unity. Oh, there is some issue. Open the script again. Here we need to create a public vector3 locate2d function, and it's need a vector3 parameter called vec. Inside this, return new vector3 gameObject.transform.EulerAngle.x, gameObject.transform.EulerAngle.y, and vector2.signAngle, vector2.up, and vec. Now call this function here. GameObject.transform.EulerAngle is equal to locate2d actual join position minus GameObject.transform.position. Now save the script, go to the Unity and hit play. As you can see now, this works properly. So it's time to make a script for camera movement. Right click and create a new C# script called camera follow. Select our main camera and attach this script. Now open the script, remove the start and update method. Now create a serialized field private game object called player. Create another serialized field private float called speed. Add private rigid body component, call this player RB. And create a start method and give the reference to the player RB. Player RB is equal to player.getComponent and rigid body. Now set gameObject.transform.position is equal to new vector3 player.transform.position.x, gameObject.transform.position.y, and gameObject.transform.position.z. Now create an update method. Inside update, check player rb.velocity.x is greater than 0, and else if player rb.velocity.x is smaller than 0, then so here we need couple of variables like public float offset, public float max offset, public float min x and max x. I am just hiding the offset for now. Now go to the start method and set our offset to 0. And inside the update method, write offset plus equal to time.delta time multiply with speed. Check if offset is greater than max offset, then offset is equal to max offset. And inside the else if function, set offset is negative equal to time.delta time multiply with speed. And check if offset is smaller than negative max offset, then offset is equal to negative max offset. Now create a float called next x, and this one is equal to player.transform.position.x plus offset. Check here. If next x is smaller than min x, then next x is equal to min x. Same as it is. If next x is greater than max x, then next x is equal to max x. Now set gameObject.transform.position is equal to new vector 3 next x and gameObject.transform.position.y and gameObject.transform.position.z. Now save the script and go back to the editor. Now drag our Stickman object here. Set speed to 0.3, set max offset to 1.2, set min x to negative 1.5 and max x to 10,000 or even above. Add more joints in the scene by just duplicating the previous joints and set this in the scene. Now hit play. As you can see, our camera follow script is working properly now. Open the script folder and right click to create a C# script called Game Manager. Also create an empty game object called Game Manager. And reset the transform and attach Game Manager script here. Now double click to open this script in Visual Studio. Remove the start and update function. Now write serialize field private transform call finish line. Serialize field private camera follow. And serialize field private stickman call stickman. Save this script and go back to the editor. Now drag our main camera object here and stickman object here. Let's create a finish line. So find the finish line image. Make sure to change filter mode to point no filter. Now drag this inside the hierarchy and change draw mode to tile. Now set the width and height and place it here. Change this component name to finish line. Now select Game Manager and drag our dash line object here. Go back to the Visual Studio. Add serialize field private game object called player and serialize field private game object called particle effect. Create a start method and write stickman is equal to player.getComponent stickman. Create private vector 3 called init position and set init pose is equal to player.transform.position. Now create an update method. Go to the stickman script. Here we need to get this bool variable. We can't access this right now because it's a private variable. So create a function called public getStick and here simply return stick. Now go back to the game manager and inside the update check if stickman.getStick is equal to false. Check one more statement inside this. If player.transform.position.x is smaller than -5, then we need to reset the game. Here -5 means if player go to the left direction beyond the camera, then we need to restart the game. Now create a private void restart game function and call this function here. Same like this we did for the left direction, we need to call reset game function when player go beyond the camera y-axis. So check if player.transform.position.y is smaller than -5. If this statement is true, then run the reset function here. Let's check this. So I like -6 instead of -5. Now let's create a win logic. So check if finishline.position.x is smaller than player.transform.position.x and create a private bool won and add here. Don't forget this exclamation mark and set the won is true here. Now create a private void win function and call it here. Now open the Stickman script, create a public void reset, set vector 3 parameter call init position. Here set rb.velocity is equal to vector 2.0, rb.angular velocity to 0, gameObject.transform.position to init position, gameObject.transform.rotation to new quaternion 0, 0, 0, 0. Now go to the game manager. Inside the reset game function, write stickman.reset and add here init position. So this is it for the reset game logic. Now let's write a win logic inside the win function. So when player passes the finish line, we need to slow his movement, play the particle effect, slow camera movement and finish the level. So let's tackle this one by one. First, let's add a particle effect.set active to true. Also, set particle effect.transform.parent is to null. Now create a enumerator finish level function. Here write return new and wait for at least 3 seconds and add scene manager.load scene, add index to 0 which is the current scene right now and call this function here. Now let's slow the player movement. So save the script and go to the Stickman script. Create a public void win with float parameter called speedwin. Let's create a private bool won variable, make this false. Inside the start, initialize this to false as well. And inside the update, check if won is not true, only then we need to call check input function. Now inside the win function, set won is true and sprite render.flipx is equal to false. rb.gravity scale to 0 and gameObject.transform.Euler angles is equal to locate 2D and rb.velocity, or rb.velocity is equal to rb.velocity.normalize multiply with speed win and rb.angular velocity is to 0 and at the last set sprite render.sprite is to win sprite. Now call this function in the game manager. Stickman.win. Now create a serialized field private float speed on win and add this variable here. Let's slow the camera movement. So open the camera follow script, create a public void win. Inside this, set the max offset to 0, gameObject.transform.position is equal to new vector 3 player.transform.position.x. player.transform.position.y and gameObject.transform.position.z. Now write camera, call this cam, and get the camera component here. Now set cam.orthographic size divide equal to 2.5. Create public float orthographic size after win and set this to 2.5. Now add this variable instead of this hard value. Save the script and go to the game manager. Now call camera follow dot win function. That's it. Save the script and go to the Unity. Select the game manager object. Actually, we don't need to serialize the Stickman reference here, so remove the serialize field. Now add Stickman object here and set speed on win to 0.2. Now right click in the hierarchy and add a particle effect here. Also drag particle object inside the game manager. We can create an effect later, but first let's test the game. So as you can see, now it's working. You can customize the finish line and move it anywhere in the X direction. Now let's create a particle effect. Make this particle system a child of a Stickman object. Now reset the transform. Change duration to 1 and start lifetime to 4.5. In the start color, choose a gradient. To create a gradient, click here, edit the location and choose the color. Now close the tab. Change the simulation speed to 3, emitter velocity, rigid body to transform, and set max particle to 300. Now open the renderer, go to the material and choose sprite default material. Now set the rotation to -60, 270 and -180 and Z position to 1. Also reduce the X scale to 0.1 and Y and Z scale to 0.5 and disable this object. Now hit play. No, it's not looking good. Okay, so free this object, enable it and change the scale to 0.1, 0.1, 0.1. Now once again make this child of a Stickman object. And disable it. And now test. Okay, so now it's look good. Let's create a trail. So select the Stickman object and add a trail renderer component. Now set the width like this. Change the time to 0.25 and select the default particle system material. Save the scene and test the game. Okay, so it looks good. Go to the script folder, right click and create a C# script called shadow. Double click to open this in Visual Studio. Remove the start and update function. Now create a serialized field material called shadow material. Create another serialized field private vector2 called shadow offset. Create protected sprite renderer called sprite renderer. Protected game object, shadow game object. Protected sprite renderer, shadow sprite renderer. Now create a start function. Inside this function, give the reference to a sprite renderer. Our shadow game object is equal to a new game object, shadow 2D. Make sure to write the same name. Also write shadow sprite renderer is equal to shadow game object dot component sprite renderer, and shadow sprite renderer dot sprite is equal to sprite renderer dot sprite, and shadow sprite renderer dot material is equal to shadow material, and shadow sprite renderer dot sorting layer name is equal to sprite renderer dot sorting layer name, and shadow sprite renderer dot sorting order is equal to sprite renderer dot sorting order. Also add shadow game object dot transform dot parent is equal to game object dot transform, and shadow game object dot transform dot local scale is equal to vector 3.1, and shadow game object dot transform dot rotation to game object dot transform dot rotation, and shadow game object dot transform dot position is equal to game object dot transform dot position plus vector 3 shadow offset. Save the script and go back to the editor. Now select all the joints and add the shadow script. Create a folder called material. Here, right click to create a material. Rename it called shadow. Now select GUI text shadow. Choose the color and alpha and select the joints and add a material here. Set the Y offset to -0.07. Now it's time to create a tile where our stickman can jump. So right click in the hierarchy, create a game object, rename it to tile. Reset the transform. Now add a sprite rendered component. Choose this tile image. Resize it to 0.5. Now add a shadow script here and Y offset value to -0.07 and choose this material and test. We need to create a shadow for our stickman, but the problem is our player is not static. So we can't use this shadow script here. So let's create another script called dynamic shadow and open this script. Remove the start and update method. Also remove the mono behavior. Instead of, we can use shadow script here. So we can use the shadow scripts variables. Now create serialized field private bool is dynamic. Serialized field private float called max offset. Serialized field private camera follow called camera follow. Now create a late update function and check if is dynamic is true. Shadow sprite renderer.sprite is equal to sprite renderer.sprite. Shadow sprite renderer.flipx is equal to sprite renderer.flipx. Create float offset and set this to 0.1. Now check if camera follow.max offset is not equal to 0, then offset is equal to camera follow.offset divided with camera follow.max multiply with max offset and multiply with 100. Now set offset divided equal to 100 and set shadow game object.transform.position is equal to game object.transform.position plus new vector 3. Open the shadow script and remove the serialized field private instead of use public in shadow offset because we need to use this inside our dynamic script. And add shadow offset.x and shadow offset.y plus new vector 3 negative offset 0 and 0. That's it. Save the script and go back to the Unity. Select the Stickman object and attach the dynamic shadow script here. Go to the material folder, duplicate this shadow material, rename it and choose the color and set the alpha. Now attach this material with the script. Check this dynamic option, set shadow offset to negative 0.01 and max offset to 0.1. Select the main camera and drag it here. Okay, so save the scene and hit play. Shadow offset.y is too low right now, so change this to negative 0.07. Feel free to choose the color and the shadow offset according to yourself. Our shadow offset is changed in shadow script because we change it to public. So re-add the shadow offset.y to negative 0.07. So it's time to create a logic for our tiles. We already created a tile. Now we need to add a capsule collider 2D in it. Inside this, change the direction vertical to horizontal and make sure our collider set properly. We need one more capsule collider in this object. One is for the colliding and the another one is for the checking the trigger. Same as it is, change the direction mode, set the collider like this and make sure to check this trigger box. Now create a folder called animation. Select the tile and go to the Windows. Now select the animation. Hit the create button. select the location and rename and save. Now hit the record button. Make sure you select the tile object. Move the animation bar and reduce the Y scale a little bit. Again, move the bar and increase the Y scale. At the last time, move the bar and set the Y scale back to its original scale. Now hit play and see. Yeah, it looks good, but let's change this keyframe. Increase the X scale in this key. Yeah, it's good. So this animation looks slow for me. We can make this animation fast by just reducing the length of these keyframes. Now select all the keyframes, right click and select both tangent to linear. Now select the animation clip and uncheck loop time. Double click here to open an animator window. Now right click and create an empty state. Rename it called idle. And make this empty state a default state. Now again right click and make a transition to tile animation. Make another transition tile animation to idle state. Select the parameter. Select the trigger parameter. Set the name to touched and select this transition. Now click on this plus icon and remove the has exit time. So our animation is set. Now it's time to call this animation whenever layer collide with the tile. So go to the script folder, right click to create a new C# script called tile. Attach the script and double click to open it. Now remove the start and update function and create a private animator called anim. Inside the start function, give the reference to the anim. Create private void onTrigger 2D function. Rename this to other. Inside this function, write anim.setTrigger. Add a string called touched. Make sure to write the name correctly or just copy this name from here and paste it. Now save the script and go back to the editor. Now one last thing we need to do is go to the material folder, right click create 2D, add a physics material 2D, rename it called bounce and set bounciness to 1.2 and the friction to 0. Now select the tile object, open the capsule collider and drag our physics material here. Create another folder called prefab and drag our tile object and make this a prefab. Create an empty game object, rename it called tile manager, reset its transform and make this object a parent of tile object. Now duplicating this tile prefab and set it inside the scene. So now it's time to check the final outcome. So this is the final outcome. We made it.
Thank you for watching. Subscribe now and press the bell icon. Never miss any update.